Have you ever wished you could go back in time? Maybe to witness a historical event firsthand, or to right a past wrong? Perhaps you dream of traveling to the future to see what technology awaits. The idea of time travel has captivated humanity for centuries. It's a staple of science fiction, fueling our imaginations with stories of adventure and intrigue. But is time travel truly possible? Or is it destined to remain in the realm of fantasy? While the ability to hop in a time machine and journey through the ages is still purely theoretical, the nature of time itself is a fascinating area of scientific exploration. We experience time as a linear progression, a constant flow from past to present to future. But what if our understanding of time is incomplete? What if time is not a river, but an ocean, with hidden depths and currents yet to be discovered? To grasp the possibilities of time travel, we must first shift our perspective on time itself. We typically think of ourselves as existing in three dimensions: length, width, and height. But there's another dimension we experience every moment, even if we can't see it: time. This is not just a philosophical concept, it's a fundamental aspect of the universe as we understand it. Albert Einstein, in his groundbreaking theory of relativity, revolutionized our understanding of time. He proposed that time is not absolute but is woven together with space to form a four-dimensional fabric called space-time. Imagine a trampoline as a representation of space-time. A bowling ball placed on the trampoline creates a dip, a curvature in the fabric. Similarly, massive objects like planets and stars create distortions in space-time, and these distortions are what we experience as gravity. One of the most mind-bending implications of Einstein's theory is time dilation. This phenomenon suggests that time is not experienced at a constant rate for everyone. Time can be affected by factors like gravity and speed. The stronger the gravitational field, or the faster an object travels, the slower time passes for that object relative to someone experiencing weaker gravity or traveling at a slower speed. This might sound like science fiction, but it has been experimentally verified. Atomic clocks, incredibly precise timekeepers, have been flown on airplanes and sent into orbit. Upon their return, these clocks showed a tiny but measurable difference in time compared to their Earth-bound counterparts. The clocks had experienced time dilation, just as Einstein predicted. Astronauts aboard the International Space Station, orbiting Earth at high speeds, also experience a slight but measurable time dilation effect. Perhaps the most famous illustration of time dilation is the twin paradox. Imagine identical twins, one staying on Earth and the other embarking on a high-speed space voyage. When the traveling twin returns, they will have aged less than their Earth-bound sibling. This isn't just a thought experiment, it's a consequence of how time and space are intertwined. If time dilation occurs with the speeds we can achieve now, imagine the possibilities near objects with immense gravity, like black holes. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. As you approach a black hole, time would slow down dramatically relative to an observer at a safe distance. Let's say you could get incredibly close to a black hole and somehow survive. Time would pass so slowly for you compared to Earth that you could, in essence, travel to the future. Spend a few hours near the black hole, and years, decades, or even centuries could pass on Earth. When you return, you would have effectively leaped into the future. However, this form of time travel only allows for forward jumps, not journeys into the past. Traveling back in time poses a much greater challenge. While future time travel is theoretically possible within the framework of general relativity, backward time travel bumps up against logical paradoxes and the fundamental laws of physics. However, some intriguing possibilities have emerged even if they remain highly speculative. One such concept involves wormholes, hypothetical tunnels that connect two different points in spacetime. Imagine folding a piece of paper in half and poking a hole through it. The hole represents a shortcut, a shorter path between two distant points on the paper. Similarly, a wormhole could potentially create a shortcut through space-time, connecting distant regions and perhaps even different points in time. Another theoretical possibility is the existence of closed, time-like curves, paths through space-time that loop back on themselves. These curves, if they exist, could allow for travel through time in both directions. However, the existence of closed, time-like curves remains highly speculative, and their properties are not well understood. Traveling back in time raises a host of logical paradoxes. the most famous being the grandfather paradox. What would happen if you went back in time and prevented your grandparents from meeting? You wouldn't be born, but if you weren't born, you couldn't have gone back in time to change things. This paradox highlights the potential for contradictions and inconsistencies when considering backward time travel. One way physicists have attempted to address these paradoxes is through the many worlds interpretation of quantum mechanics. This theory suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes, each representing a different outcome. In this view, traveling back in time wouldn't change the past of your original universe, it would simply create a new timeline, a separate branch of reality. While time travel remains a tantalizing mystery, it's important to separate science from science fiction. Time machines like the DeLorean from Back to the Future or the TARDIS from Doctor Who make for captivating stories, but they are products of imagination, not scientific blueprints. The laws of physics, as we currently understand them, present formidable barriers to building a working time machine. The quest to unravel the mysteries of time is far from over. As we delve deeper into the fabric of the cosmos, we may discover new and unexpected ways in which time can be manipulated. Perhaps one day, what seems like science fiction today will become the science fact of tomorrow. Until then, the allure of time travel will continue to capture our imaginations, reminding us of the vastness of the universe and the endless possibilities that lie hidden within the fabric of space-time.